we are really talking about some cool technology this week on Webinar Wednesday. We're going to get into that in just a minute, but as a way of teeing up the discussion, I want to share a story with our audience. As some of you know, I had my manufacturing world really set on end, totally transformed about 6 years ago, 5 or 6 years ago now, when I took a trip to Japan. We were at a plant just outside of Tokyo, and what I saw there totally changed my view of advanced manufacturing. As somebody that had been in manufacturing for 23 years at that point, 24 years, totally changed my view of the manufacturing world. We're going to talk about that. It was an amazing trip to Japan. I got to go to the Japanese Disney World. Yes, there actually is a Disney World right outside of Tokyo. Very, very cool to see. We visited these amazing Shinto temples, these temples that have been around for centuries upon centuries, beautiful architecture. We saw these cemeteries that were carved into the side of mountains, absolutely beautiful and historic in their own way. Had an opportunity to see parks. We visited all of these great parks where people were spending time together, enjoying the outdoors. We did some shopping. So I walked through several shopping districts. I did not try the world famous ice cream burger. I did see that, but I did not try it. Nor did I try some of the other interesting foods that we saw in Japan. I did get an opportunity to go to the top of the Tokyo Tower, which was fascinating. In fact, if you watched the Olympics this summer, you saw that gigantic radio tower in the middle of Tokyo. I had an opportunity to go to the absolute top of that. I did try the green Kit Kat bar as well, and that was actually pretty good. So I did a lot of really cool things on that first trip to Japan. And a lot of these are kind of touristy, but we also spent time in amazing manufacturing operations. I went to a manufacturing operation at the base of this mountain. If you've been to Japan, or even if you haven't, you may recognize that as Mount Fuji. And we were at a manufacturing facility that literally comprised 23 million square feet. Now, I ran the largest contract metal finishing operation in the United States for several years. That was 250,000 square feet, and it was huge. Imagine a manufacturing operation, 23 million square feet, but that's how big this was. And we went into one of the buildings on that campus. And here's where my manufacturing life was changed. They had these gigantic machining centers. You could maybe fit one of them in a large bedroom. That's how big they were, gigantic machining centers. And they had these autonomous forklifts driving all over the manufacturing floor, picking up material, taking that material to a robot. The robot would load the material into a machining center. The machining center would machine it, give it back to the robot. The robot would give the material back to the AGV, and the AGV would take it to the next operation. It was absolutely fascinating to me to see this 300,000 square foot building on a 23 million square foot campus running 24 hours a day, 5 days a week with just 12 people, thanks to automation. And it was at that time, 5 or so years ago, when I realized that manufacturing as I knew it was totally changing. Well, here's the point. We talk a lot on Webinar Wednesday about the exponential economy, the idea that products are doubling in price performance every 12 to 18 months. That means that what I could buy 18 months ago, I can buy today for half as much, or spending the same amount of money as I did 18 months ago, I can buy twice as much product and technology than I could 18 months ago. Well, we see that in areas like smartphones. We see that in areas like smart sensors and smart devices. Well, guess what? This is alive and well in the world of autonomous vehicles and autonomous mobile robotics as well. The point of that is, as amazing as that AGV, that autonomous vehicle that I saw 5 years ago was to me, that technology, that market has completely transformed since that time. That's right, in the last 5 years, completely transformed in that particular market. That is what we are going to be talking about today. And so it's my pleasure to introduce a new relationship for us here at ATS Lab Midwest. As you know, we are on the cutting edge of every single technology: robotics, automation, smart technology, smart sensors, smart devices, augmented reality, machine learning, artificial intelligence. We're going to talk today about how we combine a number of those different technologies into one really amazing solution, not just for manufacturing, but specific to our discussion today, to the world of education. So for many people in education, especially in the area of research, the name Clearpath Incorporated is probably not new. You know that these folks have been doing some amazing things in the education realm. We are introducing today their Director of Strategic Alliances, a gentleman by the name of John Stykes. And John is going to be talking all about Clearpath's sister company, OTTO Motors. So John, let's begin by welcoming you to Webinar Wednesday. Thank you so much for being with us.
I'm glad to be here and glad to talk to you. And we're really excited about this opportunity to work with y'all.
We're so excited.
Education is a great place for us. It's just such a fantastic place for us to work together and help shape what the industry is becoming.
And that's really what it's all about, right? It's shaping what the industry is becoming, shaping the future of education. And as we shape that future, I know one of the very first questions that our audience is going to have is about this autonomous technology to begin with. So from 30,000 feet, why is autonomous technology becoming so prominent in the world of industry, John?
Well, it's a really simple answer, honestly. When you look at where things in industry, where you create value when you create something new. You don't create value when you transport something from one place to another or do something that's very repeatable, very trainable over time. We've seen that in the industry for years with static arm robotics, where they do repeatable, replaceable, replicatable tasks over and over again. And it's a great place for robotics. And we're finally to a point technology-wise where we can transport goods in a very seamless way that is additive to an operation and is the next big step to connect these various pieces or islands of automation we found in manufacturing.
So very, very fascinating. You know, in my days of manufacturing, we talked a lot about, you know, your value add is really doing the things that your customers pay you to do. And the truth of the matter is that there isn't a customer of any manufacturing operation that pays people to move material around the manufacturing floor, right? So the more efficient we can make that process, the more flawless and the faster we can make that process, and the less expensive we can make that process, the better off we are. Again, because that doesn't necessarily add value for a customer. It's necessary, but it doesn't add direct value. And that's where these autonomous mobile robots come in. Tell our audience, what exactly is an AMR, John?
Yeah, great question and good tee up, because when we've seen these AGVs that you saw 5 years ago, an automatically guided vehicle took things from point A to point B. If you think about it very much like a conveyor, a lot of people will call it an AGV virtual conveyor. Well, an AMR is the next step in that. Autonomous mobile robot means that the robot itself and the system that it's connected to understands the task at hand and understands the best path to complete that task, as well as the intermediate steps to complete that task. So autonomy means we give the system, hey, go complete this list of tasking, and the system and the robots will work together to figure out how to do it without it being very prescriptive, much like a conveyor. So if you think about it, an AMR is much more like a person driving a forklift or a piece of equipment to a facility, more so than a conveyor belt moving through a facility. A conveyor belt is much more like an AGV.
So you really started to touch on the difference between automation and autonomy, and there really is a difference. And so talk a little bit about when we talk about automation and maybe more repeatable tasks versus autonomy, where we have a unit that is making decisions for itself, communicating with other devices and sensors and so on. Help us understand, what is that difference, John, between automation and autonomy?
The big difference that we've seen is autonomy allows for flexibility in task delivery. And what I mean by that is when you do something and you just make it automatic, it's exactly the same thing. When a robot arm picks up something and places it directly in the same spot over and over again for the next 5 years, that is a very automatic task. Same thing with a vehicle. If I'm picking up from one end of line, let's say a palletizer, and I'm going to a wrap machine, and I do that forever and always, that's a great automatic use case. Problems come in when it can't navigate around obstacles, can't navigate around different things. And that's where autonomy comes in, because autonomy allows us to program a route or a workflow to go from the wrapper to the palletizer, but also utilizing the same vehicle to then go from the wrapper to maybe an outbound shipping dock or maybe to a storage location. And you begin to see fleets and teams of robots working together to work together as a true team in an autonomy setting, where they're making decisions or working well together. And it's a much higher level of flexibility.
Interesting. When I think about my years in manufacturing, one of the things that you would see is you would see fork trucks driving all over a facility, picking up material at the dock, maybe unloading a truck, putting it away, picking it up at the dock, bringing it out to the manufacturing floor, moving it from operation to operation. And the people that were driving those vehicles, those fork trucks, if you will, they were responsible for making lots and lots of decisions, making sure they were working safely, working in and around workspaces where people were working, avoiding other vehicles. Maybe they get to a spot where there's somebody who left a container in the middle of the aisle where it wasn't supposed to be. Now, all of a sudden, I've got to figure out how to navigate around that piece of equipment or that container, maybe even going around another piece of equipment to get where I'm going. And it sounds like you have these autonomous mobile robotics to the point where literally they can make those types of decisions for themselves. I think that also kind of raises another question in my mind, and perhaps the minds of the people in our audience, and that is those people that were driving those fork trucks, the people whose job it was to pick up material, take it to a manufacturing operation, to take it back to the shipping dock, to load and unload trucks. As we make these robots think more and more like people, in some ways we are taking those jobs that people used to fill in the world of material handling and replacing them with robots that no longer need a person. So I know that's going to beg a question on the part of our customers and on the part of the individuals who are on the webinar today, which is what happens to these jobs that are being replaced by these autonomous mobile robots?
That's a great question. It's one of the ones we get very often. Is it taking the jobs from people? And really what we have seen is in very rare cases does that happen. In most cases, it's an upskilling. What we end up seeing, the people who were formerly driving a fork truck are reallocated to doing a higher value task or retraining to now maintain the system or be the one who goes and maintains and makes sure that the robots are doing what the robots are supposed to do. So what it is we take out the dull, dirty, and dangerous work that's happening in these factories and replacing the robots for people to not have to do the dull, dirty, and dangerous. And again, it's all about task reallocation and labor reallocation because it is not a result of COVID. There's been a labor challenge market for years in manufacturing. And COVID, I think, really just highlighted that this is not a problem that's going away and it's only exacerbating. So let's take that really central resource that we have in the market, which is people, and put them in the highest and best use of their time, not moving things around a facility. That's not the highest and best use of time of the most critical resource we have in manufacturing, and it's the people.
I think you ask a really good question, which is for every one of us, what is our highest and best use? And I think the truth is, as we're all seeing in manufacturing, that an individual who can think on their feet, who has the right skills and abilities and competencies, their highest and best use is rarely moving equipment around with a forklift, racking and unracking, or preparing manufacturing equipment. If we can automate those responsibilities and those tasks, I think the manufacturers are better off, and to your point, the people are better off. We put them in much more interesting career choices. I was at a conference just yesterday full of industrial manufacturers, and one of the individuals that was serving as MC said, raise your hand if you're not having problems filling positions in your manufacturing operation. And you can guess how many hands went up, and that was absolutely none. So the truth of the matter is that the way we look at automation, the way we look at robotics, is it's not replacing people on the shop floor. It's enabling manufacturers to meet demand with their customers and to be able to continue to produce product in this era where there is definitely a shortage of talent, and particularly skilled talent in the world of advanced manufacturing, which I think leads us to the next question. We look at this equipment, and this isn't your grandfather's way of running a manufacturing shop, right? It's very, very highly automated. We're relying on complex hardware, complex software, creating amazing jobs and opportunities for people as a result of that. Tell us about the hardware and the software that students will be learning with AMRs.
Yeah, great. And this is especially from an education perspective why we're really excited about this, because we want an educated workforce. So when they come into the industry, they've seen these LiDARs, they've seen these motors, they've seen these gearboxes from a hardware perspective, they've seen the lifts, they know how electronics work, they know how all the hardware works. And then from a software perspective, they understand how software enables that hardware to do something in the physical space. Because what you're seeing on the screen right now is a great representation of hardware and software working in concert. we're seeing that we need students and folks moving into the industry who understand that when the LiDAR picks up a target, as you see when the vehicle driving around, it's telling the software what it sees in the environment. The software is building the blue line with the path to be planned, and it's constantly evaluating, working in concert between the LiDARs, between the wheel telemetry or odometry, and the vehicle's understanding of where it is in space, as well as its understanding from software of what task it's supposed to accomplish. So there's a tremendous wide variety of skill sets we need to put it all together.
So we ask our audience to think about what's more interesting, a job driving a forklift, and nothing wrong with that job. And certainly there are still plenty of people that make a living driving forklifts, moving material and manufacturing. But what's more interesting, driving that forklift or understanding this amazing technology that we're seeing on the screen, all those different technologies that you just mentioned, John, working in concert to be able to move material, move product, move boxes around any type of a facility, a logistics facility, distribution facility, manufacturing operation, and so on. So I know one of the questions I think that our audience is going to have as they're looking at this is, yeah, really, really cool technology. Great for students to be learning this, whether it's at a technical college, a university, certainly even a high school. But what are some of those real world applications for this learning once they get out in the field, once they've been through this curriculum, once they've learned how to interact with the hardware, with the software? What does the future look like, and what are the applications for those students when they get to the workplace?
Oh man, I'll tell you, from leading the partnership group here at OTTO, I spend most of my time talking to folks that we work with to go to market, our integrator partners, our end user customers. And I'll tell you, days don't go by that I don't hear about 4 or 5 opportunities where we need skilled people to come in who know the pure technology. How does the vehicle actually work from a service and maintenance perspective, from a deployment perspective, from a software perspective in terms of design or maintaining or updating or building these workflows? Because what we saw in the previous clip, we sat down to deploy this robot and we had to design out the workflow of what the robot was supposed to do. So that took someone who understood the physical world and what physically needs to happen in that facility, as well as understand what the technology is capable of doing, and put those things together. So what the real world applications are from a solution design perspective is understanding how that mashup between human and physical world meet. It's a great opportunity for people who want to go down pure engineering paths to understand how the physical vehicles go together, how you can make them more efficient, how they can move more predictably, all the way to people who are much more on the workflow and operations focused, who understand technology, but will work on how we apply the technology that's built in our engineering houses.
So really, really interesting career opportunities for our students, really regardless of which discipline they're going through during their educational journey, to learn these competencies and then put them to work once they get into the workplace. So for some really incredibly rewarding and interesting careers. Now, John, you and I have talked, and you know that I'm not a hands-on kinesthetic learner. I'm sorry, that I am a hands-on kinesthetic learner. I'm not a book learner. I'm not the learner that sits in a classroom and looks at a chalkboard or a whiteboard and just gleans information that way. The more interactive the learning for me, the better. I think the other thing that we've touched on here is that there are a lot of different applications for autonomous mobile robotics. It's not just the unit that is finding its way around the floor using artificial intelligence, machine learning, smart sensors, smart devices to do that, but it's interacting with all of these other technologies. And as we put up this photograph with a beautiful Fanuc robot in the back, I love the fact that you've got that Fanuc robot on your website. As you know, they're a fantastic and amazing partner of ours. As we look at this photograph and we think about your product in an industrial or a warehouse setting, interacting with all of these other technologies, give us an example or two of a project or a task that the students will be doing on the OTTO Motors platform when they encounter it in their educational journey.
Yeah, so great question. And this is a really fantastic picture to go along with that, because one of the best things in the educational journey is you'll learn how systems like the Fanuc robot work. You'll learn how systems like OTTO works in the autonomy. But most importantly, when you start looking at how systems like this go together, you'll learn how they integrate. And you learn how to help them talk to each other from a workflow perspective, as well as a technology perspective of what makes sense and what does work, what doesn't work, how do you build that out? And so what it really allows you to do, and one of the reasons I really like this approach with OTTO, is you have a fully safe system in auto. Our vehicles all have their safety systems on. They cannot be turned off. So they are safe when you're working with them. They are safe when you're working on them and moving them. And you're able to go in and program the robot to do various things in the physical world to see how it interacts and start to use the integration capabilities to integrate to the other modules that you may already have in your education setting of how do I get it to when I'm building a pallet with my FANUC that says, hey, pallet is full, come pick this up. And the auto comes and picks it up and takes it to another place. Or I need an empty pallet to go pick up an empty pallet and bring me an empty pallet. And you start to see how two fantastic technologies that are completely different interact together. This is an example of what we call an island of automation, where the island is the static arm robot, and we're using the auto as a bridge to go to the next piece of automation, which in this case is most likely going to be a wrap machine. It's going to go from here's a full pallet over to a wrapper and going to be wrapped for outbound shipment. When you start to look at your educational pieces, you're able to train on the technical side of that, the business application side of that, the maintenance, engineering, and reliability side of that, as well as on just the business side of what workflows make sense.
So a whole host of different competencies that our students are learning as they're going through this pathway. I think it's really interesting, the analogy that you draw, John, using the islands of automation and then the bridges between those islands, because that is exactly what's happening. It's connecting various systems of automation within a manufacturing environment from one to the next, which is in many cases what we're asking our electromechanical technicians, our automation technicians, our automation engineers to do and to vision out when they are putting together manufacturing operations. I just appeared last week on a podcast that was supported by the National Science Foundation, and the host of that podcast asked me, what are some of the things that you hear from industrial employers that are highest in demand when it comes to individuals they are bringing in from technical colleges and community colleges from a technician standpoint? And I will tell you that the number one thing that we hear from an industrial employer on the technical side of things is the ability to integrate different technologies. And your answer that you just covered there shows that this platform, this up and coming curriculum, and the system that you have put together, and we've helped work with you to put together, addresses that question of integration of different technologies perfectly. How do we integrate a static robot with an autonomous mobile robotic system that is servicing an entire manufacturing facility or distribution facility and so on? So fascinating technology, fascinating answer to the question. And with that, I want to, Melissa, I've just been watching our Q&A from the audience light up here over the course of the last 10 minutes. So clearly we've got a lot of interest from our audience in what we're talking about today. What are we hearing from the audience? What do they want to know?
Absolutely. And I'll just build off that. Matt, thank you. Thank you, audience members who have already been submitting questions. Keep submitting them. We have the remaining minutes that we'll use to fire as many of these as we can to John. And John, since you touched on it in your last answer, and since it's been asked, I'll just throw this out there. Can you talk a little bit more about the safety protocols that are built into the auto?
Yeah, so one of the great things about being part of the Clearpath Auto team is we've been around for a very long time. We're a 12-year-old AMR company, which is about as old as you can get in the AMR world. So we sit on the safety councils. We work to help write those safety standards across, and we build them as job number one. So for instance, when you have a vehicle, you cannot make it unsafe when it's in autonomous mode. It will always maintain safety. So when you're driving it, it's not going to impact, because what we believe, the first thing and only thing that's important in a facility is safety. The second thing is quality. And then we're going to be productive if we do those first two things right. So that's how we've engineered, that's how we design, that's how we solution. And that's the way we go forward.
Excellent. All right. So this one's a little bit more of a detailed question. So what knowledge do the students need to know? Advanced feedback control strategies, adaptive control model, predictive control, PID, fuzzy logic, neural networks, etc. Are any of these things that students need to know in order to use the auto?
Not need to, no. And that's one of the great things about auto is it's been designed to be very user-friendly from an applications perspective. For the deep learning in terms of how to design the actual physical robot, many of those technologies are going to be something that would be very interesting if you're going to go into the robot design part of the business. But to simply take the robot and understand how it can be really useful in the manufacturing space, not at all. The user experience and design criteria around how to make them successful, quite honestly, it's very graphical. It's very easy to click, point, and drag. And we're building that fantastic curriculum, and I'm really excited about deploying with you on how to train people better to use it.
Absolutely. And, kind of building off of that answer, because we talked about, how it's easy to use out of the box, but there's also the ability to get kind of really deep into some of that more heavy, the AI stuff. Would you say that this is more appropriate for a technical college program or a university program, or kind of where does it fit in when we're talking higher ed?
I think it really depends on what the students in the education system wants to really highlight. When you start talking about the technical school piece, those, in my experience, tend to fall more towards the engineering piece of how do you physically work on the vehicle? How do you make it? How do you take it apart? How do you put it together? Understand the physical, electromechanical pieces, where the university tends to skew a little more towards the AI portion and some of the machine learning elements to it. You can use it for either. It's a great platform to learn both, because you get to see the technical pieces as well as the software pieces in concert together.
That's a great answer. Yeah, thank you for clarifying that. Matt, I'm actually going to direct this next answer or next question to you. For our audience, we love here on Webinar Wednesday to just kind of share best practices and emerging technologies. This is has been a webinar all about AMRs, but we perhaps might want to clarify a little bit more strongly about our partnership with OTTO Motors. So, the question is, what is the name of this course and technology, and how can I access it? So, Matt, do you want to talk about our partnership here?
Of course, Melissa, and thank you for that question. And in as much as we don't make Webinar Wednesday about selling products, people who join us regularly know that's not our purpose here. Our purpose is to expose our audience, to expose technical education, both live and on YouTube thereafter, to really, really cool technologies. But for as long as that question was asked, we're more than happy to answer it. And that is that we will be announcing over the course of the next week a new partnership that we have with OTTO Motors to distribute their products to education across 7 US states, Michigan, Western Nebraska, and the Dakotas, and everything in between. So if you fall into that space geographically, you are in luck, because we are working together to create a package of learning that includes hardware, that includes software, that includes e-learning, curriculum, teacher training, and so on. A number of other items that are kind of included in that package that we are bringing to market within those 7 states. And so the short answer is that be happy to chat with you. We'll take your name down. We can have somebody reach out and say, here's what the partnership is, here's how it looks, and here's how you can get started, because we're so excited about this technology and what it is going to do for the world of education. We can't wait to get it in front of customers.
You're absolutely right. Our team is so excited about this technology. It's just incredible just seeing it and learning more about the OTTO team. And we're really excited to see this go into the schools in the Midwest. And because I don't want to ignore some of the folks who have asked this question on pricing, curriculum, hardware, all of that, feel free to reach out to us. You can email me directly. You will get an email with the recording of this webinar. You can also respond to that, but please reach out to us. We'd love to have that conversation with you individually offline. But Matt, that looks like all we have time for audience questions. So I will leave it to you to wrap up today's webinar.
Absolutely. Well, thank you again, Melissa, for producing and for all the work and putting everything together week in and week out. That's absolutely fantastic. Want to make sure that we go way out of our way to thank our guest today, John Stikes from OTTO Motors, from Clearpath Incorporated, just doing amazing things in the world of technology, both on the manufacturing, industrial, and distribution side, and as we've seen today, on the education side. So very happy, John, to be partnering with you. Thank you so much for joining us today. And with that, we're going to look forward to next week. We are going to do a best of Webinar Wednesday next week, where we will be highlighting some of the coolest moments from, as Ms. Melissa suggested, almost 2 years of weekly webinars. As you can imagine, that gives us tremendous amount of content, and we're going to be sharing some of those snippets with our audience. You won't want to miss that. You'll learn a little bit. We'll have a little bit of fun looking back at the experiences that we have had here on Webinar Wednesday. So with that, as you know, we are here every single Wednesday at 2 o'clock. We will see everybody next week.